So I'm guessing a lot of you have heard of Rube Goldberg, but maybe don't even know who he is. Rube Goldberg was a guy way back when that he drew up all kinds of goofy stuff, and then he made things. He was into like turning simple machines into crazy things. Some of you have maybe heard of Rube Goldberg machines or Rube Goldberg machine competitions, where kids or even adults are given certain things they can use, certain criteria they have to follow or come up with, and have this outcome. And their machine might do all kinds of crazy stuff and then have something as simple as dropping a ball into a basket or something. So, anyways, this cartoon here on your packet is kind of cool when you actually look at it. It's a Rube Goldberg cartoon, and it says down here the professor's invention for peeling potatoes. So let's look at this. It says a mechanism is a device that transmits the flow of power from the input movement to the output movement. Examine the Rube Goldberg cartoon below. Find the input and locate the different mechanisms until you reach the final output of the cartoon. So let's just go through this. You're going to go through it with me and follow through. So we got the professor here sitting on a pile of books. Apparently, he couldn't afford a bench or didn't have a bench handy. And he's pedaling away, right? So we've got rotary motion here with a real small pulley. And then the belt, which it looks like rope that he tied, goes up to this very small pulley here. But now it is spinning a really big one. So now we have increased speed or torque, right? We've changed. So mechanisms are there to change four things or up to four things. One of the things we know this just changed, or two of the things we know it changed, is speed and torque, right? Because if you bring up one, you bring the other one down. I don't even care right now if you know which one it did, but let's just say, okay, we know it changed speed or torque. Now this goes to a smaller pulley here, which is once again changing speed and torque. Then it goes to a little bit smaller one that's on here that spins this, that drives this belt, which drives this gear. So we have changed, we're talking rotary motion all the way, right? We haven't changed the type of motion. We've redirected it, right? We've redirected it. We've kind of changed the direction all the way from here to here, right? Going through this process, but it's still rotary motion. So now look though, it's rotary motion that we can say is like vertical, right? Up and down. So now look, this spins what's called, we talked about this, a pinion gear. This is actually a crown and pinion. We talked about that in that, I talked about it in that Mechanisms Toy Box PowerPoint. So we've got this pinion gear spinning this crown gear. Now, think about this. What did this change? Maybe it changed speed and torque. It's hard to tell if their size is the same or not. But we definitely know it changed what? It changed direction. Because look, we've got this spinning what I guess we could call vertical, and this spins along a horizontal. So it changed our direction by 90 degrees. Now you look at this, he's got this fancy deal in there that's holding a fork, and the fork is spinning because she's got a potato on the fork. So now we have taken this rotary motion here and did all those things to make this potato spin. Now the professor's wife here has got her finger on this knife, and you can see it pivots right here. So that, remember, that is oscillating, because anything that pivots or rotates around a pivot point is called oscillating. So she pushes down on that handle, the knife blade comes up, it peels the potato peels drop into here. And when the potato's all peeled, what does she do? Yep, she pulls on the rope. And that rope then goes through this loop all the way up to here and makes the bell ring. So what's the movement of the bell? The bell oscillates, right? Because it's going to swing back and forth. So we changed probably linear motion here with her hand pulling down on the rope to oscillating on the bell. Now, some might say, well, wait, her hand reciprocates because it goes up and down. But actually, if she pulls one time, the bell's going to rock back and forth and ring. So we'd call this linear, this oscillating. So, yeah, kind of crazy to do all that stuff just to have that happen. But that's what Rube Goldberg did, was crazy stuff like that. So now what I want you to look at is on the next page, it's got a chart that shows you what rotary looks like, what oscillating looks like. It explains it. Linear, one direction, reciprocating, back and forth. So the arrows show you what these do. I'm not super crazy about this one. I think it'd be more an arrow that kind of points out, but with just an arc to it. So number 5 here, put an X through that with your pencil. I'm not going to make you do that one because that's what we just talked about on the cartoon. And it's kind of hard to, what I want to say, it's hard to say where a mechanism's located and what its purpose is referring to the cartoon. So it's kind of tough. So don't worry about that part. And then I am going to, in the next video, show you how to do these conclusion questions.